session is focused on matching variables that you have either collected or accessed from a secondary source with the types of statistical tests you intend to run. So what do you need to know? Okay, so to start with, you need to understand the key variable types. Are they measurement related, or are they coded into categorical values? Also, it is important to understand the difference between the dependent and independent variable. In a lot of statistical tools, such as SPSS, it'll ask you to identify the dependent and independent. And if you have those flipped, you're actually going to get different responses. And because, especially in a program like SPSS, the computer may not even recognize the difference because the categorical values may actually be coded as numerics. So it's important for you to really understand. That's also important just from good research design to understand those differences. Okay, so I'm a public health guy. So it sounds like, looks like a fair number of you are public health. So I tend to use examples that are in the public health area. But if you're in other disciplines, I'm sure you can think of other examples that are kind of similar. The body mass index is a good example of a variable that can be used in multiple formats. So that's why I've selected this as an example. And so for those of you not familiar with the body mass index, or BMI as we affectionately refer to it, it is the ratio of your weight to your height. And to make matters even more complicated, it is expressed in the metric system as kilograms over meters square. BMI can be expressed as a continuous variable. So a normal range is between 18 and 25. 25 to 30 is considered overweight, and over 30 is considered obese. You probably didn't know you were going to get some health education in this lecture as well. So you get kind of an added bonus. So you might have a number, an actual number. Let's say your BMI is 32.6. That number can also be expressed as a categorical value. In this case, it would be in the obese range. In the case of categorical values, it could be classified as an ordinal, which is an ordered set of values from, say, underweight, normal, overweight, and obese. So the continuum of numbers goes through those sets in order. That's why they call it an ordinal value. In other words, you go from normal to overweight and then to obese. They're not like, you don't go, from normal to obese. The numbers have to go through that spectrum. It can also be expressed as a dichotomous variable, which in this case would be obese or not obese. And finally, it can be expressed as the individual components. Because this is actually a calculation, you could express it as weight and height. So let's take a closer look at what those classifications mean. You'll find that in many data sets used for statistics, all of the variables are related in numerical units. It's important, however, to distinguish between a variable that is measurement related. For example, the absolute value of the BMI of 32.6 is a measured value. In fact, 32.6 is higher than 25.4, and it's lower than 36.8. So there's a range, there's a value associated with that. Other variables may be categorical, including dichotomous, nominal, and ordinal values. Dichotomous variables have two possible responses that are mutually exclusive. So yes, no, true, false, male, female. Nominal values are named values, such as ethnicity or the types of disease, while ordinal values are in ordered sets that are assigned a rank, such as normal, overweight, obese, or mild, moderate, and severe. It's also important to differentiate discrete from continuous variables. A continuous variable can be anywhere within a range of numbers and can be broken down into smaller and smaller units. If you're using time, for example, you could measure it in years, but also break it down to days and minutes and even seconds. Other variables may be measurement-based, but cannot be broken down. For example, the number of children in a family. That's an interval value because you can only have whole numbers, such as 1, 2, 3, and so on. So you can have an average or a mean of 1.5 children per family, but you couldn't ever have 1.5 children in any one family. Why do we care about this? When statistics the variability or the variation is critical. And discrete values, if the number of options are limited, so let's say the discrete value only had 3 options, then it's going to affect the variation in that data set compared to a continuous variable. Part of the challenge of getting your variables into the proper format is managing your data set in the first place. If you're using a secondary source, you really have much less control over data definitions. But if you're collecting your own data, how that data are managed is very important. The first step is properly defining your variables. Also, validating the variables by defining ranges and formats is a good way to avoid having unusable data. So maybe there's typographical errors or misspellings that, frankly, when you get back to it, you can't even use. And finally, you should consider how you're going to deal with missing data and as well as outliers.
Could we go back to the discrete and continuous?
Mm-hmm.
One other way of remembering them is one is measured and one is counted. That
yes,
kind of
that's right.
Makes it easier to remember where you are.
Yep, absolutely. Okay, so keep in mind that some variables may look numerical but are really categorical, but have been coded into the data set. In this case, gender is a dichotomous variable, so male and female. Ethnicity is nominal. Education is ordinal, and age and weight are numeric, interval data. All right, here's an example from an actual data set in Excel. Kind of small to see the numbers. You don't have to see the numbers. I just want to give you an example. So you can see that the interval data in the form of blood pressure are in the columns on the left. You can also have data or variables that have been calculated, changing the data, the variable from a continuous variable such as blood pressure to an ordinal variable such as blood pressure class. You can have age, an age variable that is calculated from a date variable. And finally, you can have frequency variables in the form of, in this case, the very last column, the number of readings. So again, in a real live data set, sometimes you get a whole bunch of different types of examples there. In Excel, the variables can be defined on the Home tab. Functions can be inserted to perform calculations. Conditional formatting can be used to evaluate or validate and also trend your data. Here's a view of that exact same data set in SPSS. SPSS prefers numeric data. So in many SPSS data sets, all of the variables will be coded as numbers, including numeric. Using numeric data is much easier to manage, and you can avoid simple data collection errors such as misspellings. If you go to the variable view in SPSS, you will see how these data have been coded. The variable view is used to determine the variable type, such as the labels, so that your data can be converted back to a categorical value. So if you're using SPSS, it's a good idea to be able to understand the data view as well as the variable view and understand what all of those columns refer to. To begin thinking about data, how to match your data to the right statistical test, it's important to know the research questions you're trying to answer and the hypothesis you're trying to test. Are you trying to define a population using descriptive statistics? Are you using testing for differences between 2 or more groups? Are you testing for relationships between 2 or more variables? Or are you comparing the frequencies using non-parametric measures? What are the dependent and independent variables? And are these measurement-based or categorical? And how is your data collected, captured, and coded in your data set? And are you collecting the data, or is it coming from a secondary source? So these are kind of questions you should be asking as you're designing your study. The dependent variable is the outcome of your that you're studying, while the independent variable is the process or intervention used to impact the dependent variable. So if you're studying exercise and fitness, exercise is the independent variable and fitness is the dependent. So exercise is the thing that you do, and fitness is the outcome you're hoping to achieve. If you have a diet and weight loss study, diet is the independent variable and the weight loss would be the dependent variable. In the study of sodium intake and blood pressure, the sodium intake would be the independent variable and blood pressure is the dependent variable. Why is this important and why do we care? Because you really need to correctly identify the independent and dependent variables in order to do the test correctly. I always had a mind block. I could never remember which was which. So that's why I try to use a couple of different types of examples there, just to help you kind of get that in your mind. So now we're going to start talking about the some of the common statistical tests and the types of variables that are required, and these include t-tests, analysis of variance or ANOVA, correlation and regression, and chi-square. Descriptive statistics and graphical representations are not used to test hypotheses, but do also require an understanding of the variable selection. When you're running descriptive statistics, there are two primary types: continuous variables that calculate measures of central tendency and dispersion, such as the mean, median, and mode, and the standard deviation, standard error, and confidence intervals. It does not make sense to calculate the mean of a categorical value that has been coded as a numeric. So if you've been coded gender as 1 for male and 2 for female, a mean of 1.5 doesn't tell you anything. Categorical values, therefore, will use frequencies or numbers or counting, as Sarah mentioned. There are three types of t-tests: a one-sample t-test, an independent samples t-test, and a paired t-test. A one-sample t-test is used when you have a continuous variable and a known result. If I knew the mean GPA of the students that I tutor, and I wanted to compare that value to the GPA of all students taking stats courses, I could use a one-sample test. An independent samples test uses a continuous dependent variable and a dichotomous independent variable. Okay, it's important to understand that. Continuous dependent, dichotomous independent. If I had a sample of stat students and wanted to see if the GPA were higher in students that had been tutored, with tutoring being coded as yes or no, I could use an independent samples t-test. So their scores would be the dependent, and whether they had been tutored or not would be my independent variable. Finally, if I wanted to compare the GPA of students before they began tutoring and after they had been tutored, so I had literally a pre-tutoring GPA or a score and a post GPA or score, then I could use a paired samples t-test. Analysis of variance, or ANOVA, is used when...
I was just going to say about the ones... Yeah, it's think of it like quality control. You know, Pepsi Cola thinks there's so much soda in their cans, and so that's one variable. We take a sample of them, see if what's on the label. And in dichotomous, I think that SPSS calls factors, right? We basically think of different groups, contrarial or the groups. And the paired t-test, my favorite, weigh in, do some exercise, weigh out, and hope that you lost some weight.
Yep. Yeah, so the paired test, you would have the same individual with two sets of scores. And so you would have two different variables, both that are both continuous variables. And yeah, and I think even in SPSS, they call it a grouping variable for the independent samples. The key to understanding that is that it's two levels. I use the term dichotomous, but what it really means is there's two levels. Okay, and so to differentiate with ANOVA, analysis of variance is used when there are more than two comparison levels. So I have a data set of blood pressures, and I wanted to compare the mean blood pressures, which is my dependent variable, to their ethnicity. And I had more than two levels. So let's say I have white, African American, and Hispanic. So I could do a one-way ANOVA on that group. If I wanted to add another independent variable, say their gender, then I could do a two-way ANOVA. Okay, so again, I have two categorical values as my independent variables, and I could test for the main effects of both ethnicity and gender, as well as the interaction between ethnicity and gender. And if I wanted to keep adding nominal values as independent variables, then I could use an n-way, or I just could keep going, n-way ANOVA. If I wanted to measure blood pressures every 3 months for the next year, and so I had 4 blood pressure readings, then I could do what's called a repeated measures ANOVA. And if I thought that maybe the BMI was a covariate in this, then I could do what's called an ANCOVA, analysis of covariance, and actually add the BMI as a covariate. So there's a lot of different ways you can approach this. So the ANOVA and the t-test are very similar. They're both comparing the means of 2 samples, but it is easy to get them mixed up. The main difference is that t-tests are used when there are only 2 points of comparison, 2 levels, a pre or a pre and a post. ANOVA is used when there are multiple points of comparison, so more than 2 levels or serial measures. You cannot just use multiple t-tests because you increase your chance of what's called a type 1 error. The next big area is correlation and regression. So these are tests used to measure the relationships rather than the differences. So a simple linear correlation includes 2 continuous variables, and the product is a correlation coefficient, or an R value. Regression is similar. A simple linear regression also contains 2 continuous variables. In addition to the R value, it produces a line of best fit represented by the dependent variable, which is Y, an intercept, which is A, the slope, which is B, and then the independent variable. Therefore, if you know the independent variable, you can predict the dependent variable using the equation you may have heard of, Y equals A plus BX. In multiple regression analysis, there will be additional independent variables added to the model. Logistic regression can be used when both of the independent and dependent variables are dichotomous, and if the independent and dependent are categorical, then you would use multinomial logistic regression. It's a little bit more complicated and advanced, beyond the scope of this lecture for sure. And then finally, chi-square is used when you only have frequency data and it compares observed to expected frequencies. In my BMI example, if I had a sample BMI and gender, so not the mean of the BMI, but the number of individuals above 30 and below 30, and I compare that to their gender, male and female, I could create a 2x2 table, and so the variables in the chi-square must be categorical. You're not comparing means, you're comparing numbers in this case. Finally, just a few comments about graphs. Because much like the statistical test, the variable type can determine the type of graph that you may choose. Bar charts are commonly used, and they can use to measure means of groups, as shown in the graph on the left, as well as frequencies, as shown in the chart on the right. Pie charts are used to show proportions and can only work for categorical values. Line graphs show numeric values, and they're usually expressed, say over time, or some unit that would make the line make sense. A box plot, or box and whisker plot as it's sometimes referred to, uses continuous variables and illustrates the range. So the middle line of the box is the median. The upper and lower horizontal lines of the box represent the middle 2 quartiles. So it goes from the 25th to the 75th percentile, and then the vertical lines represent the range. And finally, a histogram is used with a continuous variable and illustrates the distribution of that variable. This is a great way to see if you have a normal bell-shaped distribution, but again, would not make sense if you're using this for a categorical value. Okay, so in summary, it is important to know the type of variables that you'll be using in your research. Make sure that the variables can be used in the statistical tests that you have selected to answer your research questions. So always draw that line back to, why am I doing this study? What are the questions that I'm trying to answer? Excuse me, what is my hypothesis? And then you start selecting variables and tests. Okay, and when you're in doubt, always seek out help from your chair, your committee member, your professor if it's in a course, and also your tutor as well. So with that, Kim and Sarah, I think we're ready to start go into audience questions. We'll open this up.
Jeremy, I want to collect data on African Americans that may have been racially profiled based on media influence. Which approach should I take for collecting data on gender and age group?
Right. So again, always the answer to that is what I just mentioned, is what research question do you have in mind? And that will kind of dictate the type of variable that you're looking for. You know, the the ethnicity is pretty straightforward, and that's always going to be collected as a categorical and a nominal value. There's no ordered set to ethnicity or race. You know, age is kind of like my BMI example. Age could be captured as a measurement value with the actual age. It could also be captured as you know, different age groups. Again, it depends on what you're looking for. My preference, where possible, even if your analysis is going to use age as a categorical value, if you can capture it as a continuous variable, you can always take the continuous variable age, or in my case, the BMI or the blood pressure, and convert it to a categorical value. You can't do the reverse. If you collect it as an age group, then you're limited. If you wanted to go back and do you know, a comparing means like a t-test or an ANOVA, you're not going to be able to do it because you don't have the specific data.
And there was a question of whether with diabetes you could use logistic regression.
You certainly could use logistic regression if you're using, so logistic regression is designed specifically for dichotomous variables. So if your diabetes was yes, no, then certainly you could use logistic regression. And that's for diabetes, you know, typically you either have it or you don't, you know, unless you're looking for a specific component like the diabetes control, like a hemoglobin A1C, for example. But certainly you could use logistic regression in that case. It's a little bit more advanced. You know, this is a great example of where, you know, utilizing our tutoring services to just help you figure out, you know, we've got, you know, Sarah, and we just have other just awesome tutors that, you know, can really help you. You know, we can't do your study for you. We don't want to own your study, but we can certainly provide support for you in helping you figure out some of these decisions.
Hey, Pat.
Yes.
Hi, Pat. It's Kim. There's a question here from There's a question here from Alyssa. She wants to know, when would you use a MANOVA?
Yeah. So MANOVA is it's a very advanced method. MANOVA is used when you have multiple dependent variables. Typically, you know, when you're doing, you know, multivariate analyses, you'll have one dependent and multiple independent variables. So you're trying to predict, you know, one factor from a variety of other factors. In the case of the MANOVA, it's kind of flipped around, and you have multiple dependent variables. And a good example, an example I've seen is looking at like mutual funds and the stock market. So you have, you know, the stock, you know, the average stock price, you know, of different types of variables. But that would be a MANOVA. But I would venture into a MANOVA very cautiously, you know, get support from your methodologist for sure, and support from the tutors.
Pat, I was going to say that the diabetes example without a research question could be almost anything. You could do chi-squared and say, does the country you come from have any relationship to having diabetes or not? So that would have made it non-parametric categorical. You could have used it logistic. Do you have it or not? And what are the predictors that could be giving it to you? So you could have, you could use it in like you showed. So I think that that's probably the best example of why you need to be sure that your research question is basically stating what you want to find, because
Mm-hmm.
if you're not exact, then you'll have a problem deciding which of the tests to use, and your results won't be answering the question.
Absolutely.
If I'm looking at a fact associated with immunization coverage like age, sex, race as independent variables, and immunization coverage dependent variable, what test statistic should I use?
Yeah. So again, going back, so every question to this is, why are you doing this study? What are the gaps in your literature? What are the research questions? And then, in the case of immunization coverage, maybe tell us a little bit more, Albina, about what does that look like? Is that a dichotomous variable? You're covered or not covered? Is it a nominal value? Is there a way to actually put a measurement value to it? I don't really know. I'm not a immunization expert by any stretch of the imagination, but a lot of how you are able to collect that variable, like I mentioned with many of these, the more detailed you can get in your data collection. So if you can actually make it a measured value, you can always convert it back to a categorical, if possible, and if it makes sense.
Okay. When do you use bootstrap analysis?
Sarah, I don't use Bootstrap a lot. I think it's used many times when there's when some assumptions of your test. That's a whole nother lecture I didn't get into, but you also have to be looking at the assumptions for the test. So, for example, t-tests and ANOVA are really rely on having a normal distribution and equal variance, and several other assumptions. I think bootstraps sometimes are used in some cases when some of those assumptions are violated. But beyond that, I'm not an expert by any stretch on bootstrap.
Me neither, but the way I see it is that we just don't have enough. So if we don't have enough, we bootstrap, and
we bootstrap it. Yeah.
Creates more of the same, so that it's pretty complicated, but it gives us enough data to work on.
Yep.
We also have a question from Jonathan. I'm surprised there's not an algorithm which can be used to determine the type of test to perform.
Well, if you go back to my very busy slide early in the presentation, there are some algorithms that you could try to follow. Ultimately, there are several different things that you have to consider. A, what are you trying to accomplish? B, what types of groups are you looking at? C, what types of variables do you have available to you? And that really then becomes your algorithm. And based on that, then you have, it's kind of like it's a differential. You can start knocking things out because they're not categorical or they're not continuous, and eventually, and sometimes you have choices to make. Am I doing this as a chi-square or a t-test? And again, a lot of that, you really have to go back to your own literature. You have to go back to, what am I trying to answer here to really get to that? And it's always better to be doing that before you've actually collected your data. Once you've collected your data, there's probably no worse feeling than you've spent 6 months collecting data only to realize that it's not useful to you, and then you have to almost like redesign your study. That would be a horrible feeling. So I think we are getting close to the end. I'm going to actually have, I think, Kim, you're going to talk.
If you have any questions about our center, please email us at asctutoring@waldenu.edu. Thanks again, and we hope that statistics show that you'll have a wonderful day ahead of you.